All right, so we're going to go through these two quick examples now of annuities and perpetuities. So our first thing that we're going to be looking at is this question about Liam, who's investing $750 per year into an annuity at 6% per annum for 8 years. Now, I know it's an annuity, two reasons. One, they've gone through and initially just said it was an annuity. That's nice. But the fact that this investment that they're making is happening at the exact same time every single interval and concurrently up to a certain point, I know that that's indicative of what an annuity is doing as well. It is a concurrent thing that just keeps on going and going and going. It's the same amount, it doesn't change, and that's what Liam's done for his investment. Now I've gone and done the liberty of writing out this formula that we're going to need for it. Now it's asking for what is the future value of the annuity. So I've gone and looked for the future value annuity formula, which is saying A, which is my future value, equals my M, which is my payments or investments that are happening at the same time every time, equals this whole section over here, which we call the future value growth factor. And that growth factor is a value that is always the same if your term and your rate is the same. And hence why we can use a term and rate table, because those factors that they're going to change by are going to be the same they're going to be the same if they are the same term and same interest rate. So we can actually set up a table that runs down with a vertical column of terms, and it can have a horizontal column of interest rates, and you can work out with your interest rate and your term and bring it to a certain point and go, okay, there's my factor. And that factor is all based on $1, which is great because most of the time we're going to be working with lots and lots and lots of dollars. So all we need to do is multiply by however many dollars we're going to have, which is M, our payment value, and it will work out what is our future value for the annuity. Now, I tend to use this formula here myself, so I'm going to paste that there just for a little bit more familiarity. The one that you will be likely seeing on your formula sheet will be this top one. And I just know that I've used in the past, and I have used with my class, I think so far, I've been using FE for future value, and I definitely have been using PMT for payment. So same sort of thing. The reason why they try and stick away from PMT is because technically you're not always making a payment. Investment doesn't necessarily mean a payment. So we're going to just be doing some substitution. We're looking for the actual future value, so it's already in the setup that we're wanting. So I'm going to just do the next line underneath. So we're going to go future value, which is the A value. We're going to do the payment that is consistent, which is 750. We're going to multiply that by everything that's in the brackets. So we're going to be doing 1 plus. Now the I value is going to be very important. We need to work out two things first. One, is it in a percentage or is it as a decimal? Usually it will be as a percentage, so we need to alter that. And we need to look at whether it is per annum or whether it's compounding at a certain rate. Now, we can see that his is compounding annually, and it also gives us that rate as a per annum. So firstly, if you're looking at per annum and going, okay, awesome, it's already yearly and just skipping, you need to be making sure that it's not compounding differently. So this one says that it is compounding absolutely fine. It is already in that year. So all we need to do to get our I value is we need to do our interest rate and divide it by 100. And we keep it going. So power of N. Now N is the number of terms. Again, if this was compounding, you would multiply it by whatever that compounding period is. We've just got years and it's compounding yearly. So I would go to the power of 8. That's my term. Make sure you put your take 1. There's a lot of people that often forget that, because they're too concentrated on all of the other complicated parts. We've already worked out I is going to be that 6 divided by 100. And we end it all off with our brackets. Whoop. Try that again. There we go. All right, and so all we need to do is go and solve for that section. All right, so when we type that into our calculator, we will get, I'll keep it with my 750 times by. Everything that's in the bracket as our growth factor will be 9.897. We can double check that this calculation is correct by just going up to our table of future values, and we can double check what's happening here. So if I go down 6%, and we know that's what it is. It's not compounded any differently. If we go down 6% and we stop at where it is 8 years, which is right here, 9.8975. So that's exactly the same thing that we're going to be rolling with. So good, we know that we are on the right track with our value that we've got. So if we take that value and times it by 750, we end up with a future value of $7,423.10. So Luke, after investing $750 per year for 8 years at a 6% per annum interest rate, he ends up with $7,423, which, if we're thinking about this in terms of how much money he's actually invested into it, if we do 750 times by 8, he's only invested $6,000 into it. So making sure that he's gone in through this process and done an annuity, he's made himself an extra $1,400 over 8 years, which is great for such a small investment that Liam is deciding to do. All right, so let's start with question 2. And we can have a look at what the key components are. So Genevieve's grandparents are setting up a perpetuity. So we know that we're working with a perpetuity, not an annuity, straight away. They're investing $125,000 at an interest rate of 4.5% per annum. It's telling us that it is compounding quarterly, which is important because that means we're going to have to alter our interest rate for this one. So, firstly, calculate the amount Genevieve can pay off her university fees each quarter. So we're looking for the amount of payment. So we're looking for M. We're trying to find that M value. Now we know that our perpetuity formula, and I'll go and insert another equation into this. Our perpetuity formula is, and we'll get rid of that underline, A equals M on I, where M is our payment and I is our interest rate. Now we're not looking for A. We already know the overall large sum investment that they've got, and they've done $125,000. So that means if we're wanting to rearrange, we, instead of dividing by I, we times by I. So we'll end up with M by itself equals A times I, which is a nice easier formula. So we're looking for payment equals the amount invested times I. So this is where we need to start thinking about, okay, what are the values that we have? I'm going to start drawing the rest of this, I think. So we have a look at our values, and our value for A, the amount invested at the starting by the grandparents, is $125,000. So that's the large sum amount. So it pays off Genevieve's loan over time. So $125,000 for that. And we're looking at our I value. Our I value is the interest rate that we're looking at as a decimal. So we're going to do 4.5 divided by 100. And I'm going to make sure I keep that off to the left, because we also know that it needs to be altered because it's not compounding annually, it's compounding quarterly. So we need to divide by whatever our compounding period is. And our compounding period is quarters. So we also need to divide by 4. So I'm doing 4.5 divided by 4, as well as 4.5 divided by 100. And that will end us up with 0.045 divided by 4. We end up with 0.0125 as an interest rate. Cool. So going back to this, we're looking at, well, M, the amount that she's going to be able to take off the loan every single time that a payment is made at those quarterly points, will be the large sum investment of $125,000 times by that interest rate of 0.0125, which will give us M equals 125,000. Leaves us with $1,406.25 every quarter. So I can write that in after. So they've made a sum of money, $125,000, and I'm going to be taking a guess at that the amount that they're going to be paying off for a tertiary education might be a little bit more than $125,000. Since they've done that lump sum amount, that she's able to take off little portions of the loan like that off at the quarters. So that money's not going into hand. It's just she's receiving that money to pay off the loan at little intervals. So they've set that up at the beginning. I believe I made a mistake with the value that I did. I think it's 0.01125. So just make sure you double check that if you're wondering why I'm getting a different value. So let's shove that in there. All right, so calculate the amount Genevieve can pay off her university fees each quarter. She can pay off $1,406.25 every quarter. That's A. Let's look at B. Her grandparents want Genevieve to receive $2,000 each quarter. So this time they've already established, hey, hold on a moment. We don't want only $1,400 to come off every single time. We're wanting $2,000 to come off every single time. So they've established an M value this time, an M value of $2,000. And they decide to shop around for a better interest rate that can ensure that amount. Now, they haven't told us anything about how much they're looking at being able to invest. So I'm going to assume that the amount that they're going to be able to invest is exactly the same as before at $125,000. And the only thing they're looking at trying to change is that interest rate. They're looking for a better interest rate than 4.5% compounding quarterly. Now, they're still looking at quarterly payments, so we're still looking at that divide by 4 when we're trying to do this question. So let's go at inserting another equation. Let's not do that. Let's try this again, right there. Insert an equation. All right. So we are now looking at an interest value. So we're looking for what is the value of I that will work for this thing. So we already know that M equals A times I. So we can get I by itself by dividing by that A value. So we can end up doing M divided by A equals I, but we're going to have to do some alterations because we know that it's a compounding quarterly. So I'm going to leave it there, and then we're going to alter I once we work out what the initial I value thing is. So we already have M and A, so we can go down to the next bit and go I equals, our M value is 2,000 divided by the 125,000 the grandparents are happily putting in, and we will end up with a value of 0.016. So I equals 0.016. Now, that's not a percentage rate. That's not worked out what it would be per annum, and that's what we're looking for. So we've got to think about what is the alterations that we normally do with I. Now, I might do that as a drawing thing over here. Our I is normally our rate divided by our compounding period, which we're going to label as K, and it's normally times by 100. Which means we need to do a little bit of rearranging to try and work out, well, what can we do to try and work out this value here, this value of R. R is what we're really wanting to know. What is the rate as a per annum? So we can do that by going back down to here. Let's go to our next thing, and we know that I equals R divided by K times 100. So that means 0.016, since it is I, must equal R divided by K times 100. So we can put that as our fraction. We'll put R on the top. We're going to put K on the bottom, which K is our compounding period. Our compounding period for this is 4 because it's quarters. So I've got 4 times by 100, which is the same as dividing by 400. So on our next step to get our R by itself, instead of dividing by 400, let's times by 400. And we will end up with a value of 6.4. So that is 6.4% per annum, compounding quarterly. If they can go and shop around and find an interest rate that works out to be 6.4% per annum, then they will be successful at being able to get Genevieve to pay off $2,000 every compounding period if they invested the $125,000 perpetuity. Hopefully this was helpful to you. If you need any more assistance, make sure that you contact your teacher and make sure you have a go at all the questions that are on the OneNote.